Dear students, today we can go through the Kerala Engineering 2019 physics question paper. If you analyze the previous year question papers, we can observe one thing. Every chapters are equally important based on their respective amount of content. So keep in mind, based on the content, the properties of matter, heat and thermodynamics, waves oscillation, optics, modern physics, semiconductor got very important in Keam entrance. You must give also important to the principles of communication like chapters, so we can get maximum score with the minimum effort. So I want to discuss the Keam questions through 3 videos. So the first part, we can begin with the first question. See, if you are comfort with the theory part, you can attempt minimum 70 questions so easily. So that is the question structure. So look at the first question. An electron placed in an electric field experiences a force F of 1 Newton. What are the magnitude and direction of the electric field E at the point where the electron is located? So that is a very important concept. And suppose here there is an electric field, that electric field must move from the positive concept to the negative. So an electron is there, that electron is accelerated towards the positive polarity. That means, keep in mind, it must be opposite. It must be opposite. That is a very important concept. Then we know in an electric field, a charge is experienced by a force. So we can say that the force is nothing but equal to Q into E. So here, in magnitude, we can say as E into E. That is a very important concept. And here it is given that the force is as 1 Newton. So we have to find what is the electric field magnitude. It is nothing but equal to 1 by E. So that is a very important concept. So the electric field got the magnitude as 1 by E. And that force of attraction and the electric field got the opposite concept. And hence we can say the B as the answer. Look the next question, number 2. The distance between two charges as a Q1 with a value of plus 2 millicoulomb and another charge as a Q2 with a value of plus 8 millicoulomb is 15 centimeter. Calculate the distance from the charge Q1 to the points on the line segment joining the two charges where the electric field is 0. So we have to find the point where the net value should equal to 0. So that is a concept. So we can assign the point here, say as at the point as O. So our aim is to find the net electric field is 0. So here, by using the principle of superposition, that means the field due to the Q1 that should be cancelled by the field due to Q2. So we can say that the field at the point O due to 1 should got the same value as that of the electric field at the point O due to the second charge. So we can easily write as a K into what is the Q1 contribution? We can say as a Q1 by, and suppose that the separation are marked as X. So we can say as a K Q1X square should equal to K into the second charge division by the separation. We can say as 15 centimeter as a 0.15 meter minus X the whole square. So we can say the KK cancel.
the Q1 as 2 milli by x square. It should equal to 8 into 10 raised to minus 3. That division by 0.15 minus x the whole square. So are cancel. So you get the value as 0.15 minus x by x the whole square, and take the value equal to, yes, it becomes as 4. If you take the root, you get the value as 0.15 minus x by x, take the value as 2. That means 0.15 minus x is equal to 2x. So 0.15, take the value as 3x. And you get the value as x is equal to 0.05 meter. But here the choices are in centimeter. And hence we can say as equal to 5 centimeter. And you get the answer as E. A good concept, keep in mind. The third question. Good question. And here, a 4-point charges with equal magnitudes of charges of 5 coulomb, but with different signs, are placed at the 4 corners of a square of side 10 meter. Assuming that the square is centered at the origin and the configuration of the charges are as given in the figure, the potential and the field at the origin respectively are. So at first we can say, have to find what is the net potential at the point O. So that is a very important one. We can mark the charges as say A, B, C and D. Then by using the principle of superposition, you know, the potential is a pure scalar quantity. So we have to take the algebraic sum of the individual contributions. So VA plus VB plus VC plus VD. So that is equal to, what is the contribution from A? And each charges are at a separation. Say it is say R1, simply R1. So every charges are at a separation R1. So we can say as K into the first charge as potential, you know, generally we can say as 1 by 4 pi epsilon 0 into Q by the separation. So here Q, the charge as 5. So 5 by R1. And the next B charge got the minus sign, minus 5 coulomb, minus 5 coulomb. And here it is minus 5. Here plus and here plus. So plus K into minus 5. So K 5 by R1 plus VC. Again plus K into minus 5 by R1 plus 5 D contribution plus K 5 by R1. Every magnitudes are equal but with opposite sign, and hence they cancel each other, and hence we can say the net potential as 0. But the case is entirely different with the contribution to the electric field. So we can calculate what is the contribution. And keep in mind, at first we can just go through the magnitude. See the electric field at the point O, how we can find? You have to place the test charge at that point. Then find the force, then force per unit charge, that is called the electric field at that point. See the case. In each charges with respect to the center at equal separation, so that in magnitude all the 4 contributions are equal, and hence we can say the electric field at the point O due to A should equal to the electric field at the point B should equal to electric field at the point C should equal to the electric field at the point D. So what is that value? It is simply equal to 1 by 4 pi epsilon 0 into the respective charge value division by the separation as R1 square equal to. So K into the charge value as 5 by, how we can find the value of R1? See, if you just take the diagonal is nothing but equal to dB. That is nothing but equal to root 2 times of side as a 10. So we need the value of R1 is nothing but equal to dB, that division by 2. So that is equal to dB is what? Root 2 into 10 by 2. So you get the value as a 5 root 2. So you can just substitute that R1 square as a 5 root 2 square as a 25 into 2. So 5 and you get the value E as K by 10. That is the individual value. So how we can manage it? Look here at the center. So here, look the charges there. We can enlarge that figure. See at the point O, and here it is a plus 5, here minus 5, here minus 5, and here plus 5. So put the test charge here. What happened? That A value, it will ripple. So the contribution is like that. And here at the point C, it will attract it. So EC will take this direction. So two contributions one way. And here at the point B, it will attract. Good. That is EB. But the charge at D will repel the test charge. So ED. So we can say two are along one direction, but both the contributions are at the 90 degree. So along one day, EB plus ED. So it is nothing but equal to 2 into, we can say, EB. And another way, 2 EA plus EC. So equal to 2 into EA. But these two together makes an angle of 90 degree. Reason it is a square. And hence simply you can say root of this much square plus this much square plus 2 into so much into cos 90 becomes 0. So and hence the net electric field is nothing but equal to root 2 times of this value 2 EB. So equal to simply 2 root 2 into, we know the value of EB is what? As a K division by as a 10. So we can cancel. So we get the value as a root 2 K by 5. So that is a very important concept. That much volt per meter. Root 2 K. So you get easily the answer as B. That is answer. So if you know thoroughly the concept, you get the answer, no doubt at all. So that is the question number 3 with the B as the answer. Number 4, a simple question. A point dipole with a dipole moment P0K is kept at the origin. An external electric field E equal to so much value is applied on it. Which one of the following statement is true? Say, suppose we are marked as that is y axis, it is the x axis, you know, that is the axis should be perpendicular to that one. So that is our dipole is like this one, like this orientation, like the pen orientation, it is the orientation of the dipole. So the minus q charge here, the plus q charge on the bottom. But the electric field is along, say, at a particular angle. Say here it is the electric field as a 2i, minus 3, okay, fine, this fine, and plus 4k, good. So this much angle. Say the electric field is acting in this way, and the dipole is this one. But the electric field for the moment, it is a constant for that one. So in a uniform electric field, when a dipole is placed like this one, the net force acting on it becomes 0 because of the uniform field here at a particular point here. Position dependent on, but on that position it is a constant, and hence we can say uniform electric field. So the dipole in an electric field, the net value becomes 0. Net force, net linear force should equal to 0, but there should be a torque acting on it. It is nothing but equal to P cross A. So that is a very important concept. And we can prove it to be by using the determinant I, J, K, the dipole moment P only along the Z axis, and the electric field as a 2, -3, 4. You can find the concept there. The K component become absent there, only I and J. So we can say that is the answer as A. Number 4. Number 5. Find the total capacitance and the total charge on the capacitors. So here we can just convert the system. Here the two capacitors are in parallel, so we have to add together. So 1 plus 2, it becomes 3. So that net circuit become like this one, as a 3 ENF, that is connected to a potential, so that is equal to 6 volt. So here 3 NF and 3 NF are in series. Effective in series of equal concept, C by N. So 3 ENF, that division by 2, so 1.5 NF. So it is equivalent to the circuit like this one. The effective capacitance become 1 by 1.5 NF, that connected to a potential of 6 volt, and therefore effective become 1.5 NF, and the charge is nothing but equal to C into potential. So C is what? 1.5 N into the potential as what? 6. So you get the value 9 N coulomb. So you get the answer as A. A simple question. I think you get the answer. Number 6. A circuit is made using R1, R2, R3 and R4, and a battery as shown in the following figure. Find the equivalent resistance of the given circuit and the current passing through R3. So we need to find what is the current flowing through R3. That is the question, and also the total equivalent circuit. We can convert this circuit into, look here, based on these 2 points, we can say, see, at this point here R1 and R2, that are like this one, R1 and is R2 with a 0.5 value, 0.5 value, and next that R3, then that R1, and are connected in 27 volt. So that is a simple circuit. Here R1 it is given as a 0.5, R2 as a 0.5, but both are in series. So we can just convert it to be equal to 1 ohm. And here R3 already 1 ohm. And that R4 is also 1 ohm. But that 3 resistors are in parallel. It is connected to the 27 volt. So our aim is to find what is the equivalent resistance. R equivalent here, the 3 resistors are connected in parallel. So effectively, simply we can write as the individual resistance by the number. So you get the value 1 by the numbers as a 3. So that matches the effective resistance. Keep in mind in parallel, as 1 by R, take the value as equal to 1 by R1 plus 1 by R2 plus etc. But in series, it is nothing but R1 plus R2 plus etc. So that is R equivalent. Then we want to find the current passing through R3. How we can find it? You know the R equivalent. You know the effective EMF. So the current through it can be easily find out. the total current. That is equal to EMF total division by R equivalent. So that is equal to 27 division by R equivalent. So that is equal to 1 by 3. So that is a very important concept, that much ampere. But it is divided into 3. But 3 equal resistors, 1 ohm, 1 ohm, 1 ohm. So that division by, 3 I3 equal to I total. So the individually IT by 3. So you can say as a 27 ampere. So you get the answer as B as the choice. So you can easily go through it one simply. Number 7. Find the voltage and the current passing through the resistor R2 shown in the following circuit. So in this circuit here, R1 3 ohm, R2 and R3 2 ohm each, they are connected. So have to find what is the voltage and current through R2, this R2. So at first we can find what is the total current flowing through it. So simply you can convert this circuit into, see the R1, it is given as 3 ohm, and the next one here 2 ohm, 2 ohm. They are connected in parallel. So R effective is nothing but 2 division by 2, it becomes 1 ohm. So we can write, so that is equal to 1 ohm and is connected to that 8 volt. So we can convert this circuit into that R1 and this one are in series. So that resistance become 3 plus 1 become 4 ohm. That is connected to 8 volt. Therefore, the total current we can easily find IT is equal to the effective 8 division by 4, that is equal to 2 ampere. So that is the total one. But our aim is to find what is the potential across this one. So in series network, that the current is proportional to the potential is proportional to the resistance. And hence we need to find what is the across this one. So across this one, it is a parallel network. So the effective one is 1 ohm actually. So and hence we can easily find the value that is equal to 1 ohm. So that the potential across that 1 ohm is equal to that 1 ohm division by the total resistance into the total potential. So that is equal to 1 by 4 into 8. So you get the value as 2 volt. Suppose you need to find what is the potential across that 3 ohm. So that 3 ohm is nothing but equal to 3 ohm by the total resistance into the total potential as 8. So equal to 3 by 4 into 8. So equal to 6 volt. So 6 plus 2 we get the value 8 volt. So we get the half answer. The potential as 2 volt. And the next one is what? What is the current through R2? The total current we get the value. What is that? 2 ampere. So it is 2 ampere. But it divided into 2. But here the 2 resistors with the equal value, and hence the current equally divides 1 ampere. So the potential across the R2 is 2 volt, and the current through R2 become 1 ampere. So 2 volt, 1 ampere. We get the answer as E. A simple question. Number 8. Question number 8. And here, the resistor R1 3 ohm and R2 1 ohm are connected in parallel to a 20 volt battery. Find the heat developed in the resistor R1 in 1 minute. So they are connected in parallel. So we can use this circuit as say 3 ohm, and here it is 1 ohm. They are connected in parallel to a cell that is given as 20 volt. So it is 1 ohm. And here, at first we can find what is the effective resistance Rp. So 3 into 1 by 3 plus 1. So equal to 3 by 4. We can find what is the total current through it. So I is nothing but equal to E total by R effective. So E total is 20. That division by 3 by 4. So that is a concept. Our aim is to find what is the heat developed through 3 ohm. So, you can use the simple concept there. So, I across the 3 ohm is equal to the other amp resistor. That is what? 1 ohm. So, 1 ohm by the total resistors. So, 3 plus 1 ohm into the total current. So, equal to 1 by 4 into the total current as a 20 into 4 by 3. So you get the value as a 20 by 3. So that is the current through this one. I across that 3 ohm. If you know that current, simply you can find the value. Heat developed in 1 minute. Per second you can write as uh, I square into R into 1 minute. 1 minute. So that is equal to 20 by 3, the whole square into R into 1 minute. 1 minute. So that is equal to 20 by 3, 20 by 3, the resistor as 3 into 60 seconds. So if you just go through the calculation, yes, you get the value as simply 8,000 joule. So we get the answer as D as the answer. A simple question, and keep in mind, if the current flowing through a resistor, the heat developed is nothing but equal to I square R into T. So use this concept. Number 9, a simple question. The velocity and acceleration of a particle performing simple harmonic motion have a steady phase relationship. The acceleration shows a phase lead over the velocity in radians of. So you should know, as an example, we can take the displacement of a body under SHM as x is equal to a sine omega t. Then we can easily find the velocity is nothing but dx by dt is equal to a omega cos omega t. But cos omega t can be expressed in terms of sine as a sine omega t plus pi by 2. In order to find the acceleration, you have to differentiate the velocity again. You get the value as omega square, a omega into omega. The sign can be converted as a cos omega t plus pi by 2. So that is equal to a omega square. Cos omega t plus pi by 2 can be written as a sine omega t plus pi. So you just link the three, we get the very valuable information. So here we can say the acceleration is pi radians ahead of displacement, and pi by 2 radian ahead of velocity. If you just consider the velocity, they are with pi by 2. Here pi by 2 pi. So the difference is pi by 2 ahead. So you get the answer as a C. So that is a good concept but simple. Keep in mind. Then we can move to question number 10. Consider a driven damped mechanical oscillator is in resonance. Which of the following statement is true? See here, at resonance in the sense, the driving frequency is the same as the natural frequency of the oscillator. in Kerala entrance, the very, very important topic is that damped harmonic oscillator, something like that. It is a very important topic. Number 11. A body undergoing simple harmonic motion has a maximum acceleration of 8 meter per second square and the maximum speed of 1.6 meter per second. Then what is the time period? So here all the data are given. It is given that maximum acceleration, the value is equal to a omega square. So you get the value as 8. And the maximum speed, so it is equal to a omega. It is given as 1.6. So you just divide the two, you get the value omega equal to 8 by 1.6. So we can say the 2 pi by t, the time period relation with omega, that is 8 by 1.6. So we get the value for t is equal to, t is equal to 2 pi into, 16 into 10 raised to minus 1 by 8 as 2. So equal to, 2 pi into 2 into 10 raised to minus 1, you get the value as 1.25 seconds. A simple but good question. Number 12. A bat emits an ultrasonic sound wave at 33 kilohertz and receives an echo 0.1 second later. What is the distance of the bat from the object producing echo? The speed of sound, it is given as 330 meter per second. Look, the bat emit that ultrasonic sound and it strike it and rebound to here. So it travels a distance of 2x. That is a very important concept. For the time gap, it is given as 0.1 second. So simply we can say the velocity is nothing but the distance 2x division by the time t. So from that the separation s can be find out as v into t by 2. It is given the velocity v. V is what? As 330 into 0.1 the time by 2, and you get the value as 33 by 2, that is equal to 16.5 meter. So it's a good question, and that is the principle behind the very important concept also, that echo that is are used in sonar, radar, etc. Everything based on that reflection of waves. So we get the answer as E. Number 13. A wave along a string has the following equation as y is equal to 0.05 sine 28t minus 2x. Then what are the amplitude frequency? You can just relate with the general relation as y is equal to a sine omega t minus k into x. And here, the amplitude is nothing but equal to 0.05. And then angular frequency omega, that is equal to 28. And the propagation constant k, take the value as 2. So from this one, we get the value for frequency. So omega is what? We can say as 2 pi f is equal to as 28. So f is equal to 28 division by 6.28. So that is equal to 4.458. That much hertz. Similarly, for propagation constant, k is equal to 2 pi by lambda. That take the value as 2. So from that you get the value as lambda. So lambda equal to 2 to cancel as a pi. So 3 point something. So you get the answer as a 13 as A. So you should know what is this one. You should know another shortcut. It will help in the further exams. Keep in mind the omega by k, that will give the speed. That is a very important concept. Keep in mind. Look the question number 14. A train sounds its whistle as it approaches an observer standing at a point near the track. So suppose that person is standing here. The observer measures a frequency of 216 hertz as the train approaches. So here we can say that the train approaches, and that with a frequency, say we can say as a F1, and it leaves, and a frequency it is given as say F2, so that is given as 184. So F1 is given as 216 and F2 is given as 184 hertz. Then what is the frequency of the whistle? That is a question we have to answer. So during approaching, the frequency goes on increasing, so that apparent frequency we can write as is equal to the actual frequency into V by V minus the velocity of the source. And similarly, for the second case, we can write for when it move away from the observer. So we can say that say F2 take the value as F into V by V plus Vs. By using these two, suppose you just take the value of F2 by F1, you get the value V minus Vs by V plus Vs. So you can just crossing it. So that is given as 184 by 216. If you get the value as 0.851, so you can just cross it. Then you get the value V minus Vs, take the value as 0.851 V plus 0.851 Vs, and solving, you get the value. If you take the value of V as 340 meter per second, you get the value for Vs is equal to 27.36. By putting that value for F is equal to F1 into V minus Vs by V, that is equal to 216 into 340 minus 27.36 by 340 equal to as 199 point. So you get the answer. So it is a very good approach, very, very important concept to keep in mind. Number 15. The following figure is the combination of logic gates. The inputs are A and B. The output is C. Which one of the following choices give the correct matching? And keep in mind, there is some mistakes in the choices or in the question. But we can just try to write the truth table on it. So here we can just take A, B and C, and you can give A and B 0. Both are 0. Everything are 0. So here it is a roughly AND gate. So 0, 0, 0, 0. Everything 0, 0. So what is the case for 1 and 0? So 1, 0. So A become 1 and B become 0. So here AND gate, so it must be 0. So A is 1, so here it is 1. So here it must be 1, 1, 1, 1, 1. But here keep in mind, the B is 0. So roughly here it is 0. So 0. So that is the same case we observe when it becomes a 0, 1. There should be a speciality for 1, 1. If everything is 1, then there should be output must be 1. But that choice is not here. So there is something mistake, and we can just change the choice as here, and you can code the answer as E. A good question, and keep in mind there should be more probabilities there to ask one question from gates from a semiconductor. It is a very important concept. Number 16. A particle of mass m and charge q with an initial velocity v is subjected to a uniform magnetic field B along the vertical direction. The particle will. So it is given that magnetic field is acting vertically. Follow a circular path if V is along the vertical direction. The charge is moves in that direction, and in a magnetic field it is never deflected. So undeflection, that is the concept. So that answer is not good. Make a helical motion if V is along the horizontal direction. If that charge is moving like this one, surely it moves a circular path. That is a very important concept. So that is also wrong.
make a helical motion if V is neither parallel or orthogonal. So at an angle theta, so that is a very important concept. So it will undergo a Paka helical path. So we can say as C as the answer. Good question. So keep in mind the three trajectories, very important concept. When theta equal to 0 or 180, we can say a straight line path for the charged particle in a magnetic field. When theta equal to 90 degree, we can say a circular path to the charged particle. When theta equal to other angles than 0 or 180 or 90 degree, we can say it will move a helical path. It is a good question. Number 17. Consider a circular loop of radius r on the xy plane. So that circular loop is on the xy plane, carrying a steady current in the anti-clockwise direction. The magnetic field at the center of the loop, the magnitude, that is mu 0 by 4 pi into I by radius into the angle subtended. But what is the direction? We can use the circular current concept. So the current is flowing, and that is represented by the curling of the fingers. The thumb will indicate. So along the positive Z axis. So that is equal to 2 pi cancel, and you get the value mu 0 I by 2r into k cap. So you get the answer as mu 0 by 2r into I into Z cap. So that is the answer. Number 18. Consider two parallel current carrying conductors separated by a distance. See, keep in mind, if two wires, they are separated by a distance of d apart, then carrying current I1, I2 in air, they are with a force of attraction or repulsion with a magnitude is equal to mu 0 by 4 pi into 2 I1, I2 by the separation. And keep in mind here that two charges, two currents are here along the same way, and hence they are attraction. So that is a very important concept. But if the two current directions are opposite, we can say there is a repulsion is there. So here we can say what is the answer? Current flowing in the same direction will lead to repulsion. Current flowing in opposite direction will lead to attraction. So, okay, then the current will always attract, always repel. Current flowing in same direction will lead to attraction. Good. And opposite direction will lead to repulsion. So E is the answer. Good aspect, keep in mind. Number 19. The energy gap is much more in silicon than in germanium. Forbidden energy gap is more in silicon than in germanium. So it is a material dependent concept. So keep in mind. So this is the meaning. Its valence electrons are more tightly bound to their parent nuclei, and hence the forbidden gap is more compared to that one. So around 1.1 electron volt for silicon, and for germanium 0.7 electron volt. So keep in mind. So 19 D is the answer. Number 20. The dimension of pressure. The pressure is stress, pressure, everything that is equal to force by area. The force has mLT raised to minus 2 by L square. So mL raised to minus 1, T raised to minus 2. B is the answer. Number 21. The magnitude of deceleration required for a body moving at a speed 10 meter per second to complete halt at a distance of 100 meter. So the simple relation V square equal to U square plus 2AS. And here the final value becomes 0. Final velocity is 0. So initial velocity square, it should be deceleration. So minus 2A into S. So our aim is to find what is A. So A is equal to U square by 2 into S. So the initial velocity is given as a 10. So 10 into 10, that division by 2 into the distance traveled as 100 meter, so that is equal to 1 by 2, so that is equal to 0.5, that much meter per second square. So you get the answer as D, a simple question. Number 22. An accurate measurement implies that. So that is a very important concept. In the normal cases, accuracy means the closeness to the true value. So that is a very important concept. So we can say the 22 as E. So that is nothing but keep in mind that in short, the absolute value is nothing but the true value minus the measured value. It is a very important concept. So closeness to the true value, that is the minimum error. Number 23. The following plot gives the variation of acceleration with the time for an object that is started from rest at a time t equal to 0 second. The velocity at a time t equal to 50 seconds and at 25 seconds respectively are. So here, simply just to go through the figure, it is an acceleration time curve, so that is a speciality. So here, acceleration here from 0 to 10, 0 to 10, that acceleration is proportional to time. That is, it is goes on increasing. So that is a speciality. But from 10 to 15, that acceleration is a constant one. From 15 to 25, again, there is a negative concept. It is proportional to time. But you know, if you just take the acceleration into time, the area of the figure, what we get it? Acceleration into the acceleration, that is equal to change in velocity by time into time. So you get the value change in velocity. So that is a speciality for the curve. So based on that one, we can analyze the question. So at first one, see, we needed to find the velocity at a time t equal to 15 at that moment. So we can just take that area. So that area is nothing but equal to, it's a rectangle. So 15 minus 10 time into that acceleration, that is equal to 10 minus 0. So that is equal to 5 into 10. So that is equal to 50. So that is the change in velocity. Change in velocity is what? And the velocity at the moment 15 minus velocity at the moment 10. That is the meaning. So that is equal to 50. So we need the value v at 15 is equal to v at 10 plus 50. So that is a very important one. So we need to find what is the velocity at the 10 at 10. So for that, you can just take this curve. So there the change in velocity is nothing but area of that section, half into 10 into 10. So that is equal to 50. But that is what? The velocity differ, final velocity at 10 minus velocity at 0. The velocity at 0 is what? 0. So we can say the velocity at the point 10, at 10, t equal to 10 is what? 50. So you can put the value here. So velocity as the 15 is equal to 50 plus 50. So you get the value as 100. So that is a concept. And the next very important concept, and how to find the velocity at 25. And here also we can take that change in velocity in the second region, third region, that is equal to half into that time gap, 25 minus 15. So that you get the value as a 10 into that height as a 10. So that is equal to velocity at 25 minus the velocity as a 15. Our aim is to find what is the velocity at 25. So that is equal to 50 plus velocity at 15. So you know the velocity at 15 is 100. So you get the value as 150 meter per second. So based on this region, at first we take the area, that is nothing but the change in velocity at the 25 minus at 15. We already, you know, the velocity at the 15 as 100, so you get the answer as 150. So you get the answer as 150 and 15 as 100. So 23 as B as the answer. And 24. An object moving with the velocity 5 meter per second undergoes an acceleration of 1 meter per second square. If the object has a mass of 1 kilogram, the kinetic energy of the object at a time t. So our aim is to find what is the kinetic energy after a time t. So that is nothing but the velocity half mvt square. But we know the velocity after a time t is what? U plus at the whole square. So that is equal to half into the mass here as 1 kilogram into the initial velocity is what? 5. What is the acceleration? After a time what? 5. So that is equal to half into 1 into, so u plus 80, so 5 plus 5, 10, 10 square as 100, so that is equal to 50 joule. So you get the answer as D as the answer. Number 25, the last question for the session. The variation of speed of an object with time is given by the expression Vt equal to V0 minus 5t plus 5t square. At time t equal to 0, what is the acceleration? So you just differentiate that one. That is equal to, it is a constant, so 0 minus 5 plus 10t. So when t equal to 0, that dv by dt take the value as a minus 5, a negative value. So it is not correct. There is a deceleration of the object, so that is a correct answer. So that is a value. B is the answer. But what happened when t equal to 1? You can just, it is given as velocity should be 0 at t equal to 1. But not possible. It is the chance of V0 is there. Again, you can just differentiate. You get the value for acceleration. So acceleration is d square V. So here, so here once again, here Vt is equal to that much. So we just differentiate, you get the negative sign. Good, good. So here dv by dt as equal to minus 5 plus 10t. When t equal to 1, then what happened? So dv by dt take the value equal to minus 5 plus 10 into 1. So that is equal to plus 5. A positive value is there. So that is also not true. So we can conclude with B as the answer for 25. And we can wait for the next video. But keep in mind one thing. If you take minimum effort, then you can get maximum score for Kerala engineering. No doubt at all. God bless you. Take care.